Hey guys, welcome back, and today we're going to do the part 3, which is my favorite part, the math problems. Remember, you have to turn on your audio. Well, if you were able to hear me, you would have already turned on your audio, so that's a bit of a mistake by me. And take notes, because if you don't take notes, you might forget it. And before we start with the fun stuff, let's just have a bit of review, just to refresh your minds. Fibonacci sequence is a sequence where any number is the sum of the two previous numbers, like 0, 1, 1, 2, 3, 5, 8, 13, so on forever. And the ratio between any two consecutive terms approaches 1.618. That's an approximate value, not the full value, which is phi, which is the Greek way of saying it. So let's have something new today, huh? Some important fact patterns and some facts to know about it. Every third term is a multiple of 2, every fourth term is a multiple of 3, and every fifth term is a multiple of 5. So what does this mean? Other than just what is said there, what's some other external meaning that you can think about it from these facts? Pause the video right here and tell me what you think. So this means that every third term is even, and every fourth term is a multiple of 3 plus some other multiples of 3 like 6 or 24. It might be, not always. And every fifth term is a multiple of 5 and maybe some other multiples of 5 like 15 or 10. Also, back to the third term, which is a multiple of 2, this also means it might be a multiple of other multiples of 2 like 4 or 8. You might be wondering, well, how does that matter? Well, in math competitions and stuff like that, these kind of minor details are what like the hard problems use. So it's really good to know these things. Fibonacci day is November 23rd. Can you try to figure out why it's that particular date? I'll give you a hint. American date system. Pause the video and think about it. In American date notation, November 23rd is written as 11/23 because in America you write the month first and then the date. And the Fibonacci sequence goes 1, 1, 2, 3. And if you read the date, it also has the numbers 1, 1, 2, then 3, which is why it's Fibonacci day. That's an interesting fact that I thought we should talk about before we actually start with the mathematics. The Fibonacci sequence has a negative portion. It isn't just all positive numbers. So here's a few numbers from the negative portion. Negative 3 plus 2 is negative 1. Negative 2 plus negative 1 is 1. Do you notice any patterns here? Pause the video and think about it. So it goes from the left to the right, negative, then positive, then positive. From left to right, it goes negative, positive, negative, positive. So there's also a formula to find like what's the 10th term, what's the 15th term. Remember the Greek letter phi, which is approximately 1.618? Well, n is the position of the term you want to find. For example, if you want to find the 7th term, then n here, just plug in 7. So it'll become phi to the power of 7. Here's the formula again. And there's some things to note which are really important. For extremely small numbers like the first term or second term, you can approximately use 1.64 phi. For larger terms like the 10th term, use the full value or at least 1.618033988875. The closer it is to the actual value of phi, the better it is. Also, the formula assumes that the first term is 1, the second is also 1, the third is 2, the fourth is 3, the 0th term is 0, and the negative 1th term is 1, and so on. So remember to round up your final answer. If you plug it into the calculator, you'll probably get something like 0.998 for the first term, and that's basically 1. So the answer is for the first term is 1 because you just have to round up a bit. So I have 3 problems for you, and I want you guys to spend a few minutes solving it. These problems are really fun problems to solve out, and just solve it, pause the video here, solve it, and I'll go over how to solve them in the next few slides. Okay, so were you able to solve it? It's okay if you weren't, because I'm going to tell you how to solve it in the next few slides. So, how to solve the first problem, which is trying to find the first term. Phi to the power of n minus 1 minus phi to the power of n divided by square root of 5. This is phi to the power of 1 minus 1 minus phi to the power of 1 divided by square root of 5. Remember when I said for the really small terms you can just use 1.6 for phi and 2.2 for root 5. Well, 1.6 minus negative 0.6 is the same as 1.6 plus 0.6, because if you subtract a negative number you get a positive number. And 1.6 plus 0.6 is 2.2 divided by 2.2, and that's just 1. So the first term is 1. But what about the 10th term? Because I mean, it's probably a pain to have to like do solve it this normally to find like a big number like a 10th term. So plug in 10 for n here. Phi to the power of 10 minus 1 minus phi to the power of 10 divided by square root of 5. If you use a calculator here, you can get roughly 55. You'll probably get something like 54.998 or something like that, and that's basically 55. So just round it up and you get 55. Also, when you're solving this particular formula, and also almost any formula in algebra 2 and pre-calculus, whatever, always follow PEMDAS. Do the parentheses first, then the exponential functions like 2 squared or x squared, then do the multiplication, then the division, then the addition, and then last subtraction. This order is the order of how you solve things in math. And to use the formula to find the 13th term, you get 233, then you minus 55, which is the 10th term that we found in the previous problem, and you get 178. So the 13th term, which is 233, minus 55, which is the 10th term, is 178. So that's it for today. See you next time. I think we're going to start a new topic next time, and that's it. Good luck. See you next time.